Today, I want to talk a little bit about a sometimes confusing topic called scope. And scope has to do with the life of a variable and its range, kind of where we can access it from, what its uses are. There are three types of scope that we're going to touch on. We're going to touch on global scope, we're going to touch on function based scope, and we're going to talk briefly about class based scope. But for our purposes, we haven't talked a lot about what classes are. We're going to mention them towards the end of this course, but know that class based scope is the same as global or function based, just limited to a class. Let's talk, though, let's focus more on global and function based scope. So global scope, here we are in our functions py file here. And a global scope just means that a variable is accessible either file wide or application wide. Basically, it's it's available everywhere. And its life cycle exists for the length of that unit, whether it be the file or the whole application, whatever it be, as long as that piece is running, typically the application in this case, or the script, then that variable is alive, well, and can be accessed. There is a reference being held to that variable. So we could make some global variable here. And we've done this pretty often, right? We've made global variables before, right? It's just when we make a variable at the top of our script, that's a global variable. Different from that is this thing called the function scope variable. So we have this do something function, and it's going to take a number, and it's going to do something to that number, right? Let's say, for example, we want it to, I don't know, add 10 to that number. We could even make up another variable. We could say variable 10 is equal to number 10, and we want our function to return number plus the variable 10. So we have three variables now going on here. We have some global variable that we set equal to 10. Let's change it to 15, let's say, just to vary things up a little bit. We've got the variable number, which is a parameter we're passing into our function, but its scope is still the function. And we've got our variable 10 that is defined in the function, and its scope is also the function. Once that function is called and done with and over, both of those variables are going to be discarded. They're not going to be in memory anymore, or they're going to be labeled that they can be removed from memory. So let's see what I mean. Let's go ahead and print 10, the variable 10. Let's go ahead and print the variable number. And then let's go ahead and print our some global variable and see what happens. Take note of the yellow underlines that are already going on under 10 and number. And if we hover over them, we can see 10 is not defined, number is not defined. Interesting. They're defined in the scope of this function, but that's not where this print statement is. This print statement is outside the scope of that function. So when we run this, we get these errors, right? So it's saying, hey, we don't know what you mean by 10 because you're trying to print 10 out here. If we were doing this inside of the function, it would know what we're talking about 10. That's its scope is limited to that function. That's the only place where we can access it. Okay, so if those don't work, kind of how do we deal with this stuff? All right, well, we were talking about return statements. So in this case, we could print do something and pass it in some global variable. So now we should be taking our global variable, passing it into our function, which is going to create the number variable, create the 10 variable, combine them, return the result, discard those two variables. Let's see what our result is. So we get 25 and 15. I want you to pay attention to something. Some global variable is initially set to 15. Then we pass it into this function, we do this math, we print what comes out of this math, but then we print some global variable again. So 25 is what came out of our function, but some global variable is still 10. That's because Python is a pass by reference to object, language, which means that it is not going to make a change to the global variable when it's passed into here. It's instead going to make a copy of that variable, do what it needs to do to it, but ultimately not edit that variable itself. That variable is going to stay the same. Python's a little bit different, though, that it doesn't treat, because that's an integer, and integers are kind of immutable in that sense. And I guess let me show you what I mean. So let's make some other variable for a second. And we're also going to set it to equal to 15. And I want you to see something kind of interesting. If you notice, some global variable, which is set to 15, and some other variable, which is also set to 15, both have the exact same location in memory. It's referencing the same spot because it's the same value. So it sort of treats, Python treats its memory allocation a little bit differently than a lot of other languages. But all this is to say that these are actually kind of treated as the same thing with different names, kind of different ways that we're going to refer to the same thing in memory, which saves it from putting 15 into memory a bunch of different times and then having them each have their own address. So, yeah, so that's just kind of an interesting thing to know about Python. It's treating this and this as the same part of memory. We're just referencing that point in memory through two different names, some global variable and some other variable. So why am I saying this? When is this not the case? Well, let's say some global variable wasn't a integer, but was instead a list. A list in Python is a changeable object. We call it a mutable object. So we are going to change it. We're going to pass number in, and then we're going to treat number as if it's a list, and we're going to append a new value onto it called 10. And then we're going to return that list. Okay, now I want you to see something interesting that's going to happen. I'm going to call the function, and then I'm going to try to print out this variable. Now, if this were an integer, it would go into the function, the change would happen, we'd print out the result, the return from that function, and then we would print out the original variable unchanged. But now that the original variable is a list, you'll notice the change actually stays because the list is mutable, right? So it's not going to be stored in memory in the same place, and we're going to be able to say, okay, that's 1510, and now the original global variable is also 1510. This is not the same for all languages. A lot of other languages pass only by value, meaning they always copy the value and pass that in. Other languages pass only by reference, where you are always referencing that original variable, and you're always going to be changing that original variable. And so this is kind of in between, where sometimes when you pass it in like an integer or a string and you try to make changes to it, the changes will happen in the function, but the original variable won't be changed. But pass in something like a list or some other mutable object like a list and make changes to it, expect those changes to outlive the function and the return of the function itself, if that makes sense. I know that's a little bit complicated, but I just kind of wanted you to see the difference and start to have a sense of scope, because this is why scope matters, right? Scope matters because we are trying to see what the effects of our code are, what the effects of our code can be outside of things like a function, or is the scope of the changes limited to the function, right? We need to know that so that we don't make mistakes. So that's just a good difference to know. But when we talk about scope, what we're talking about is life of the variable and access to the variable. Global, access everywhere. Life exists for the life of the application of the script. Local function scope means it exists for the life of the function. When the function is done running, that stuff is discarded from memory. Okay.